Welcome to G Fun Facts Online. Imagine trying to navigate your city, but instead of a simple journey, it's a grueling obstacle course. For over 1 billion people worldwide living with a disability, this isn't imagination, it's daily reality. The very systems designed to connect us, like buses and subways, often become sources of frustration and isolation. But a technological revolution is underway, one that promises to re-engineer our cities and create a future of truly inclusive urban mobility. Today, we're diving deep into the tech that's making our cities not just smarter, but more equitable for everyone. For many of us, getting around is an unconscious act. We rush for a train, hail a ride, or follow a GPS without a second thought. But for others, every step of that journey is a challenge. Let's break down these barriers, which fall into 3 main categories: physical, informational, and social. First, the physical obstacles. These are the most obvious. Think about public transport systems built decades ago. Many buses and trains lack low floors or ramps, making them impossible for wheelchair users to board. Even if a station is technically accessible, that treacherous gap between the platform and the train can be a major hazard. And we've all seen it, the dreaded out-of-order sign on an elevator, which for some isn't an inconvenience, but a complete dead end, turning a simple trip into a logistical nightmare. The journey doesn't start at the station either. The first and last mile, the walk to and from the transit stop, is often a perilous adventure. Poorly maintained sidewalks, a lack of curb cuts, or even just a misplaced garbage can force someone into a dangerous street. Then there are paratransit services, the door-to-door alternative. While great in theory, they're often plagued by high costs, the need for advance booking, and unreliability, leading to long waits and missed appointments. This constant struggle creates what's known as transportation disadvantage, a state of reduced mobility that fosters social isolation and economic hardship. Beyond the physical, there's the information void. A lack of clear, accessible information is a huge hurdle. For someone with a visual impairment, a missing audible announcement on a train means they might not know when their stop is approaching. For someone with a hearing impairment, a lack of visual displays leaves them without crucial updates. Even with modern technology, the real-time data from transit apps isn't always reliable. This forces people to gamble with their travel plans, creating anxiety and eroding confidence in the entire system. Finally, and perhaps most insidiously, are the social and attitudinal barriers. A lack of proper training can lead to transportation staff being unable or unwilling to help, refusing to deploy a ramp or secure a wheelchair. Then there's public apathy. People without disabilities might take up priority seating or block accessible pathways, creating an environment that feels hostile and unwelcoming. We also have to remember invisible disabilities. For individuals with autism, anxiety, or cognitive impairments, the sensory overload of a crowded station and the complexity of the transit system can be completely overwhelming. The cumulative effect of all these barriers is a system that is fundamentally exclusionary for a huge portion of our population. But in the face of these challenges, a powerful combination of design philosophy and technology is emerging. At its heart is a concept called universal design. Coined by architect Ronald Mace, universal design isn't about adding special features for people with disabilities. It's about creating environments and products that are usable by all people, to the greatest extent possible, without needing adaptation. It's built on 7 principles, including equitable use, flexibility, and simplicity. In transportation, this means things like low-floor buses with wide doors. These don't just help wheelchair users. They help parents with strollers, people with heavy luggage, and anyone who finds high steps difficult. Clear, high-contrast signs with both text and symbols are easier for everyone to understand, especially in a bustling, multilingual city. The beauty of universal design is that it creates a seamless, intuitive experience for everyone, making it not just more equitable, but more efficient and cost-effective in the long run. While universal design provides the blueprint, A new wave of assistive technology is giving individuals the tools for greater independence. Let's start with navigation. For someone with a visual impairment, getting around a city is a huge challenge. But now, apps like Blind Square and Lazarillo act as an audible GPS, using a phone's sensors to provide information about intersections, points of interest, and turn-by-turn directions. But what about indoors where GPS fails? This is where new tech shines. Apps like Avelity and Bindi Maps use Bluetooth beacons to provide step-by-step indoor navigation in complex places like airports and subway stations. And it gets even cooler. Haptic feedback is taking navigation beyond just sound. Companies like WearWorks have developed the Wayband, a wristband that guides users with subtle vibrations. Imagine a haptic corridor vibrating on your wrist, telling you which way to turn, without you having to listen for audio cues in a noisy environment. Another major area of innovation is real-time information. We've all felt the frustration of showing up to a station only to find the elevator is broken. Accessible transit apps like Move It and Transit are now incorporating features that let you filter for wheelchair-accessible routes and get real-time alerts on elevator status. This is powered by the Internet of Things, or IoT. Think of IoT as the nervous system of a smart city. Smart sensors embedded in elevators, escalators, and even buses can detect everything from functionality to how crowded a vehicle is. This data is fed into platforms like Gaia Public Transport, creating a single source of truth that travelers can access on their phones, allowing them to make informed decisions before they even leave the house. Mobility aids themselves are also getting a high-tech upgrade. The traditional white cane is being reinvented. The WeWalk Smart Cane, for example, uses ultrasonic sensors to detect obstacles above chest level, like tree branches or signs, and it can even connect to public transport data to provide voice alerts about upcoming bus stops. Smart wheelchairs are becoming lighter, more portable, and can be equipped with GPS for navigation and controlled via smartphone. And what was once science fiction, wearable exoskeletons, are now a reality, providing support and improving mobility for people with paralysis or muscle weakness. Now let's tie all this together with a concept poised to revolutionize urban transport: Mobility as a Service, or MaaS. Imagine a single app on your phone where you can plan, book, and pay for any journey. Whether it involves a combination of public transit, ride-hailing, bike-sharing, or scooter rentals. The potential for accessibility is enormous. A well-designed MaaS platform is all about personalization. A user can input their specific needs: a route with no stairs, a journey with a slower walking speed, a need for a wheelchair-accessible vehicle, and the platform will generate a tailored route. It can seamlessly integrate with on-demand, accessible transport services, giving users flexible and convenient options. Cities like Helsinki, with its WIM app, are already showing how MaaS can create a more integrated, user-friendly system. As this model spreads, it could break down the barriers between different transport providers and create a truly seamless mobility experience for everyone. So what's on the horizon? The pace of innovation is relentless, and technologies like artificial intelligence and autonomous vehicles are set to reshape our cities in profound ways. Artificial intelligence, or AI, is the engine driving many of these innovations. Its ability to analyze vast amounts of data and learn from patterns is creating a more personalized and responsive transportation system. AI algorithms can analyze your travel history and preferences to proactively suggest the best routes for you. For example, it could learn your mobility limitations and automatically suggest routes that avoid steep hills or crowded areas. For transit agencies, I can optimize services by analyzing ridership data to identify underserved areas and dynamically adjust schedules. AI-powered computer vision can even analyze a smartphone's camera feed to identify obstacles, read signs, and describe the surrounding environment in audio format for a person with a visual impairment. Then there's the driverless revolution. Perhaps no technology holds more promise for transforming mobility than autonomous vehicles, or AVs. For anyone who is unable to drive, self-driving cars could offer an unprecedented level of freedom and independence. They have the potential to provide a truly on-demand, door-to-door service, completely eliminating that first and last mile problem. But to realize this potential, AVs must be designed with accessibility in mind from the very beginning. This means incorporating features like automated ramps, securement systems for wheelchairs, and user interfaces that can be operated by voice. The U.S. Department of Transportation's Inclusive Design Challenge is actively encouraging this, with projects like Purdue University's EASI Rider, a vehicle concept with an in-floor ramp and an accessible user interface. However, while this future is bright, it's not without its challenges. The very technologies that hold so much promise could create new forms of exclusion if we're not careful. AI systems can inherit biases from the data they're trained on. For example, if a speech recognition system isn't trained on diverse speech patterns, it won't work for people with certain speech impediments. The reliance on smartphones creates a digital divide, potentially leaving behind those who can't afford them or aren't digitally literate. There are also significant privacy concerns about the vast amounts of personal data being collected, and as we move towards automation, we can't lose sight of the human touch. For many, the social interaction on public transport is important, and a fully automated system could increase feelings of isolation. Engineering a future of inclusive urban mobility isn't just a technological challenge. It's a societal one. It requires a collaborative effort from policymakers who must mandate accessibility standards, from engineers who must embrace universal design, and most importantly, from the disability community itself, whose lived experiences are essential to creating solutions that actually work. The mantra "nothing about us without us" must be at the heart of every design effort. The journey towards a truly accessible city is long, but the destination is clear: a city where everyone has the freedom to move, to connect, and to participate fully in the rich tapestry of urban life. The technology to make this a reality is within our grasp. Now, we just need the collective will to build it. Thanks for tuning in to G Fun Facts Online.